In order to talk about linear graphs from the point of view of geometry, we need to take a moment to talk about the notion of similar triangles. What does it mean to have similar triangles? More generally, what does it mean to have similar shapes? Similar shapes are just shapes that have the same shape but different sizes. Now, saying precisely what this means is actually a large part of the work of a geometry course, but we can say intuitively what this means. If I draw something, and then I make a copy of it, and then I take the copy and I stretch it out so that the new picture is bigger, but it's just another copy of the same picture, we can think of these as being the same shape, but different sizes. What does it mean when we have triangles that are the same shape, but different sizes? Remember, a triangle is just a shape with three sides. So here's a triangle. And in this discussion, we're going to be really concerned with right-angled triangles. Triangles where one of the corners is a square corner. What does it mean for two triangles to be similar? Let's copy this picture, stretch it out, and see what happened. How are these two triangles related to each other? Well, notice, if I take this triangle and set it on top of the first one, the small angle matches, the middle angle matches, and of course, the right angle, the square corner, matches. If two triangles are similar, all of their angles are the same size. In fact, because of the relationship of the angles of a triangle, in order to know that two triangles are similar, we just need to know that two of their angles are equal. What about the lengths of the sides? I notice in this picture it's hard to see the relationship of the lengths of the sides. So just to make this easier to see, I'm going to make this bigger triangle a little bigger still. Notice now that in the smaller triangle, the short side is 2 squares high, and the medium side is 3 squares long. In the bigger triangle, the long side is 4 squares high, and the medium side is 1, 2, 3, 4, 5, 6 squares long. Now, those are obviously different lengths, but their ratio is the same. The ratio of the short side to the medium side is the same as the ratio of the short side to the medium side. And that's always going to happen. In similar triangles, the ratios of corresponding sides are equal. Using that, we can come up with another way that we can know that two triangles are similar. We can know that two triangles are similar if two of their sides are in the same ratio, and the angles between them agree. So in this figure, I could have known that these two triangles were similar because the short side and the medium side were in the same ratio, and the angles between them were right angles. Why is this useful? Because if we use one of these to find out that two triangles are similar, each of these properties comes along for free. And that is going to allow us to describe the geometry of lines in terms of the measurements that we see in the Cartesian plane.